go to the website, you'll see this. If you look into your booklets, you'll see that. So today you get two presentations for the price of one. So, yeah, this is a presentation about microservices, but I'm not presenting only from the technical side, but there's going to be some technical information for those of you who like the technical detail. I also want to present it as a journey, yeah, the evolution that our team really had to do to go from working from the monolith, working in the monolith to microservices. We faced quite a few challenges, and we had some good successes, and we don't call them failures, we call them lessons learned. So we learned a few lessons. Yeah. So just to kind of set the scene a little bit, I want to talk about what microservices are. Does anybody here have any experience working with microservices? Are you familiar with them? Few hands, yeah, few people, okay. So we could define microservices as a collection, a series of very small applications, fine-grained, that work together to achieve a goal, to deliver the business value. Yeah? And for instance, a typical example is you could have an invoicing microservice. And if you want to invoice a customer, then you need, of course, your customer microservice. So your invoicing microservice needs to talk to the customer one to know who to invoice. But at the same time, you need to have your products microservice. You will need to talk to the products to know what to invoice at the same time. Yeah. That's a simple example. But why do we have microservices? Well, the advantage is that you can deploy them independently. And they make your code surface smaller. So it's much quicker to iterate on them, to work on them, to deploy them. And at the end of the day, what they do is they address the code complexity. It's much easier to work on a smaller code base than just to work on a bigger one. Yeah. Now, that doesn't mean that the complexity goes away. Yeah. What that means is that you move it to a different place. The complexity is not suddenly building it, pushing it. Is how do these services each other? Yeah, how do they communicate? That's the difficult part. So this is the start of our journey. Yeah. This is Moni. This is our CPO, Chief Product Officer. He's the man with a great knowledge of the market and the vision where he wants to take the product. Yeah. And he works on this office in San Francisco. And this was the mission. Have to build a conversation analysis solution in 6 months. Yes. And this man is Arthur. He's in the audience. He's our CTO. He's the guy with a wealth of technical knowledge and a vision where he wants the architecture of the product to be. Yeah. So to make the mission even more impossible, yeah, he says, yeah, so you have to use microservices. Okay, thanks. And this is the team. Yeah? This is the team that had to build the microservices. And there was a bit of the word that we were a bit hesitant. Microservices, really? We weren't quite sure about it. So let's talk a little bit about the solution. And what's this conversation about? So we do call centers, contact centers in the cloud, and every day we have thousands of call recordings between agents and customers. Yeah? And there's one role among the customers who's the supervisor. One responsibility, coach. Okay, well, you were not that good in that call because you didn't mention our opportunities or special offers, yeah? Or you were not polite enough, you didn't greet the customer. So in order to coach them, basically these supervisors listen to calls at random. They have no better tool. They choose a few calls during the day and listen to them and then coach the regulars. That's what we want Conversation Analyzer for. We want to make that much better. Conversation Analyzer tells the supervisors what was said in the call. What did they say? Was this call good or bad? Was it polite or was it not polite? Yeah. And that's what we have to do. This is microservices. So just an overview. I don't want to get too deep technically, yeah, because I can bore you. But it all starts with the call recording. We have thousands of them every day. And we envisage, we thought of a process to turn this code recording into a text file or a key, text manipulated, and that we call the transcription service. And once we have the text, we have to understand what was said in it. That's a different problem, that's just this text analysis. And we thought about something called a categorization service, where we could identify pieces of things, pieces of information. And we literally put color dots in the UI, yeah, but the focus here is not in the UI, it's what happens in the back. So we know we're going to have the microservices, and that's the big goal. But there are a lot of decisions that we need to make to turn this into a reality. And that's what happens every time. If you want to start a journey to microservices, those of people are not there. There's a lot of questions that you need to ask and answers that you need to get. What language on the platform, what is the message format? That one nowadays is pretty free, the message format. So the team got together in a room, probably exactly what we're going to do. And we came up with these answers. Yeah, these were our solutions. The first choices that we took initially. We went for C# because we're a C# class. We use Mono. We were using Kestrel Web Server, which is the server that comes built into .NET Core. We would stop using RESTful web services. That's a no-brainer. Nowadays, pretty much all web services use that. We chose Docker. We see strong advice to use Docker. And we hosted it in our own virtual machine. We'll get into that. And we use Jenkins CI as the pipeline, and we use a stack called InfluxDB and Grafana to do automations. So before we go on, I want to talk a little bit about a couple of key players here. One of them is Docker. Does anybody here know what Docker does? Does anybody really know what Docker does? Yeah, because when we started, the language we used was, Docker is like a lightweight virtual machine. Yeah, no, it's not. It's not a lightweight virtual machine. Docker is a way to deploy one process. Actually, Docker is just one process running inside a machine. So you have three Docker images with a container running side by side. It's not that you have three kernels, three VMs. You just have one kernel running three separate processes, and they are isolated from each other using OS, kernel level separation. So you don't even know that each other exists. That's why they are quite effective. Cheaper to run on VMs, more simply effective, and so on. What they do is they actually address the infrastructure complexity. What you need to do now is deploy one Docker. Because Docker is going to play an important role here. And the other answer I wanted to talk about was our pipeline. So we use Jenkins server. It's not the sexiest server out there. It doesn't have the best and more attractive user interface, but it has the right back-end hooks that we needed for our integrations. And the pipeline team are still very proud. They said, we want to do this again. Cool. And they allow us to deploy to production environment with a one button. Some people in this room are big fans. Okay, so we got together 6 months back, we were working, packing away. Some of us were kite surfing as well, and so on. And we came up with this. These are microservices. Doesn't look very impressive. So let's take a step back and look at what we achieved. We actually, we have the 2 microservices here, both of them talking to the monolith, and they are hosted in the Docker host VM. So they're basically hosted on a virtual machine we had in AWS in EC2, that's the Amazon's Web Service virtual machine. So it was there to host our Docker images, so we call it Docker host. We're not very creative here, we just get the job done. But okay, we managed to deliver business value and to deliver features, and we have all the logic outside of the monolith. Yeah? It's not super impressive, but I mean, it's a good first step towards our grand vision of what microservices. Yeah. So what did we do well? Language. I think the language was a great success. I'm not saying that you should use Sharp for the microservices necessarily. Yeah. You can use any language that gets the job done. You know, if you're a Java house, probably Java is going to be great and so on. For us, it was very good because we didn't have to learn a new language. If the team already knew C#, why make the mission impossible, even more impossible by learning Node? Sticking to our new work for us, as many languages that will work, just leverage. Yeah? Metrics were a fantastic success. I cannot stress the importance of that. So when we started going, metrics give you a view of the health of the system much better than going to a user interface. It tells you like how many calls we transcribe and we categorize every day, how many users you have looking at that thing in the user interface. Fantastic. As I said, we went for inputs to be into a format. Whatever works for you, but you need to have metrics for microservice to know what works. That lessons, yeah, we learned mono. So when we started, the .NET Core was in its infancy, and we said, yeah, let's go for mono, it's more stable. Well, that's a lesson we learned. Eventually, we would be migrating importantly to .NET Core 2.0 because we found an issue with the network and stuff. Yeah. It's okay, it just took some time to fix, yeah. And eventually, we kind of outgrew Docker Host. So Docker Host was good for as a stepping stone to help us get further, but eventually we moved to other offerings that reason with containers. We moved to ECS, and we could leverage a platform as a service provider. Yeah. So that was the end of the 6 months, and well, the team was not very happy, I have to say. Yeah, there was we were feeling overwhelmed. There was a lot of things we had to learn. We felt that we didn't really know them deeply enough, yeah, to feel masterful. And even the result is not that it's not what we wanted to do. We also learned that we have to learn on deploys. That was a bit of a shock as well. So when we were in the monolith, a story would be done, we would check into our version control, and somebody, an external thing would go and deploy that to production and release. And I would say, but this is making my life harder. Now I need to do my own deploys. It's more work for me. Well, yes, you're probably going to have to do that. So that's something you need to be aware of. That is not a bad thing necessarily, especially as it gets more and more sleek. It gives you more control. But this was, as I said, the first 6 months, we were a bit burnt out, but we were working in production. We had a system that worked, users, was a stream of revenue, yeah, right? Well, you know him by now, yeah? Of course, we wanted the next step. I want to redact out sensitive information. What happens if some people are talking and they actually say the credit card number to the agent? We don't want that written down in our database for GDPR data protection. Yeah. And our customers were in the US. Well, of course, yeah, we wanted everyone. We went to sell in Europe, we went to sell in APAC. So, yeah. Very reliable. Everybody likes phone. Yeah. So this was our solution. And now we envisage having some sort of reduction service that will go and cross out the bits in the text. Yeah. That was we were together, we were working. we did a few things. Yeah, we as a scenario, we migrated to .NET Core 2.0, we migrated to ECS, so we no longer have that Docker host. We use Terraform to provision our resources. So Terraform is infrastructure as code. You check in some configuration files and running some clever scripts, you can provision things in the cloud. Fantastic. Also, great success. Yeah. One of our controversial decisions was to keep categorization and reduction in one service. Actually, I drew two boxes earlier, and it became one. To me, I still stand by this decision. It was controversial, but think as find and replace. Categorization is fine, you find what's in there. Reduction is replace what you want by access. They're always in the same menu in your editor anyway, yeah, they're pretty much the same feature. I don't think that's separating them would be good. So this was our infrastructure. We managed to move to ECS. ECS gave us some interesting things. Suddenly there's something called the elastic load balancers that automatically detect any instances of your containers that are running. So for the categorization service, this thing can, without reduction, this thing can grow, it can multiply. You can have many of these running. And the elastic load balancer will automatically detect any new instance of running, add it to the pool, and send more work. That's fantastic. We didn't have that with other folks. And thanks to the points of presence and all the regions in Amazon, we could have this working in 6 regions. Those of you with keen eyesight will still notice something coming here. This is HD. Well, bear in mind, this is all internal network, internal services. Nobody's accessing them from the outside, only the monolith. And they're even a bit naive because they will give you any information you ask for. But it's okay. Okay. It's looking better, yeah. This is something you're going to say, yeah. There are more boxes, so it's going to be better. So Docker was a great success. Docker was super helpful in this because it allowed us pretty much to lift and shift, take it from Docker host VM and put it on ECS. So the key here is that we somehow use the base image in Docker to isolate our code from the infrastructure. So if you're in a different infrastructure and you need to read your config variables from a different place, you tweak the base image. It applies to both microservices. And we have help for that. We have both teams. We have a lot of support from the department to do that. There's a certain amount of bleeding, so a bit of the infrastructure will get to your code. So you will have to tweak your code a little bit. But I would say it was not that painful to migrate the code base to one place. Yeah, maybe the painful side of migration was having other parts of the system talking to themselves. Yeah, ECS, as I mentioned earlier, ECS is great because it allows us to reason with containers. So you can do things that we say like scale them, auto discover new containers. You can even add permissions. You can say this container can now see that file, so this container can now talk to that queue. Before you couldn't with Docker host, you need to authenticate in a more explicit way. So that was great, yeah. What didn't work for us is by this time the system was growing and we had to move off to a different database. That was, we still do this hard work. Basically, we were using the same database server as our monolith. That service is very strict. Yeah, we want to keep the replication lag to under 1 second. And we were to deploy a new big table or outside table, other column, with a column that could jump that could risk replication lag. So we were kindly asked to find a new home for our database. Yeah, and it was also hard work with the migrations. Lesson learned, try to think about your databases from the word go. Yeah, you can get them isolated from other critical applications. This is my friend, horizontal scaling. Yeah. I pointed earlier that categorization service can scale, transcription still can't, unfortunately. We basically made a mistake, or we didn't know enough, we didn't think enough. And the way the pipeline is one of the processing of codes is done by states in the database. So we query the database, we get some states. If we have two instances in parallel, they don't work well with each other. So if you can design your pipeline, design your services so that they can scale initially, then your service will be great. Yeah, we did it. The thing was starting to say, yeah, there are things we don't know. The code base, let's face it, the code base is inside, it's not the way we'd like it, but yeah, maybe code thingy. This microservice thingy is not that bad. Yeah. Time for more fun. So our CPU says, right, customers want to in the third-party applications. The one is we want to expose this via an API. Yeah, of course, runs have version in authentication. Yeah. The thing was starting to feel a bit nostalgic, yeah. At the same time, a little bit focused. It's okay, yeah. It's towards the future. So we managed to do quite a few things. We ported to HTTPS, we added authentication, we added versioning, yeah. OIDC, open ID, blah, 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 authentication is an evolution of OAuth 2. Yeah. I'll speak a little bit more about it later. So this was when we were only now we are on HTTPS. It's time to talk about a couple more services, but they don't belong to our team. We have the API gateway, which is the single point of entry to our microservices. That's a pattern that's used apparently. It's one of the possible patterns to use in a microservice infrastructure. It's the one, it's checkable to it's a reverse proxy, the one who knows where everybody else is. External customers will go and query the ask to the API gateway, and the gateway will put you to the right microservice. Then there is a service that's still part of the monolith called the identity server. And an external customer like that would identify itself on the identity server and say, hi, it's me, username, password, like maybe whatever. They will get a token signed by this guy. And whenever they query, one of our services show the token to the API. Hey, it's you. The API will say, yeah, I recognize this token, it's signed by the right person, and you want this data source. Yeah. This is good. This is a microservice architecture. Seriously. So, yeah. The API gateway and the identity servers are a great success, yeah? Especially because there's a lot of work that we don't have to do. I love that work. It's my favorite thing on the SME. It's a microservice that another team built, and then all the services we will can leverage this. So think about this, have some sort of centralized authentication. Yeah. Basically, some of our colleagues, really hardworking people, they created packages to share the code base. So we were starting to use microservices more widely in the company. And basically, we see that there were things that we were looking in different places. And we have some really clever people who said, well, I'll create a new package of this. Yeah, I'll not publish it publicly, but we have it in an internal server. And we started leveraging that. Yeah. Of course, it takes some time to refactor, rewrite the code, get rid of the code we have, take it from the new dev. Suddenly, we can do more with less. And that's fantastic. We have a smaller code base, easy to build, test, everything. And now all of that authentication code starts working. Yeah, the lesson we still have to think about is now becoming bigger service coefficient. I justify this. I think that categorization and reduction still seems to be one. But the transcription, I see too many things. Yeah? Coordinates the pipeline, classifies, transcribe, but it's also the API to access the data. It's time to recognize that it's doing too many things, and it should be one of the things we should fix in the future, break it down. Yeah. But yeah, at this point, as you can guess, the team is saying this is pretty cool. Yeah, we're proud of it. We're proud, we're happy we created. Took a year and a half to get there, but now we're good. I had a page just from this Monday, basically, about what's reported to us in the morning. I told the reporter, sorry, I'm busy finishing this presentation. Let me go back to it. This is for next day. Yeah. Let me go back to it after lunch. So right after lunch, I picked it up. I said, yes, I can work with it. I know what it is. Fix it, and within 3 or 4 hours, it was already fixed live in production. Yeah. Because we have the power to deploy the microservices. And it was for a time critical event. We have to have it ready. That's fantastic. We wouldn't have been able to do that with monolith. So yeah, we feel ready for what's next. So Mission Impossible 4 is going to come soon. Yeah. We still have some challenges, as you know, horizontal scaling. We said these. For deployment, we still run a few too many manual checks. So we deploy, we manually check that the API is working, we make new phone calls, get the recordings in the transcript. We want to reduce this time. We need more automation. Yeah. So yeah. We're getting close to the end, and I want you to take away a few things. If you start in your journey to microservices, think about these things, yeah? You start to already know to lower the friction. I'm tempted to make a video on JavaScript, but I'm not going to. Think about, no, that was really cheap. Node.js works very well for microservices as well. Think about how you're going to deploy them. I would say that Docker works for 90% of the use cases, unless you have something very, requirements like you're very time sensitive or you need like really high availability, really low latency. You might consider other things, yeah. But Docker works very well for us. Try to leverage the platform as a service offerings, things you have in AWS or Azure. I'm sure Google has things to reason with containers as well. I just haven't done it more. Yes. Kubernetes is a layer on top of Docker, isn't it? That allows you to coordinate everything. Maybe that's our next step. So this is what's stressing the pipeline. We wouldn't be able to do all of this without an awesome pipeline behind, yeah? There are some companies that use the pipeline as a sexy name like Service Fabric or Microservices Matrix. And they have teams working. We have full team, full-time team working on improving the pipeline and giving us all the tools for this. Yeah. Now think about how you're going to next production, because the main thing that microservices do is quick deploys. So you need to have people to do the first. So yeah, the last thing I want to say is, for me, it's a privilege to be here and talk about this, but this is not my work on it. Yeah, I worked on this, but there was a lot of people behind this. Yeah, I went all the way from the top, and we had help from many teams to achieve this. That's all. Thank you very much. Any questions?
I'm impressed that you can talk about this so calmly. After all the knowledge.
So, I think never say people like me. Any other question? Was that a question? A statement? That was a statement.
Yes. Do you want to go back to normal?
No. No. Yeah.
You mentioned very quickly, why the transcription service didn't scale horizontal?
Okay.
You have some intermediate state. Right?
Basically, what the transcription service does is a job scheduler. It runs jobs every 30 seconds. Queries the database. It says, right, what calls do I need to transcribe? It gets them and it sends them to transcription. So I might have at the same time you have another transcription service working and says, what calls do I need to transcribe? And it gets the same query because the other service has not finished processing them. So you have suddenly both of them trying to process the same calls and basically stepping on each other's toes. Because maybe one says, okay, I'm done. And then he picks them up for the next step. And then he comes and says, oh, I'm done. And overwrites them. And then writing, basically the issues that they run a query databases. And that was the problem.
I can give you the MI12 slide. The one says you will implement conversation analyzer for omnichannel. And I'm going to be saying doing his messaging.
Any other story?
Yeah, actually, because it looks like a very mature product. So what's next? You force extending of this thing, or you will ask customers what you want next, or you do something completely from scratch?
Okay.
My thought is make it omnichannel because we're not processing only calls, we're processing also chats for our customers, emails, and so on. So make it work for other channels as well. Change the architecture a little bit more to kind of have the communication between services using messages. But once this is done, because these guys do the service only for customers who pay for it, I want this to be done on every single conversation that transfers. That's millions a month, millions. And then we're going to start doing analytics, applying natural language processing, all kinds of new stuff, and then try to extract more sensible information. So better understanding what's going on. But a lot, it's a creative work.
The hair of my side was black when I started.
Can you tell us a bit what is your strategy for the integration testing going on? Where did you go offline? Because it's a new paradigm in the new way of testing things.
Yeah, okay. That's a really important. You know the answer.
I know, I wanted to share with you.
Yeah. So unit tests are run usually by running NUnit or XUnit. Integration tests, we basically spin up our solution, our microservices in one container, one local container, running inside the build server. And then we run command lines, we open HTTP requests, we basically query the microservices with HTTP requests to exercise the integration. We will get tokens from an authentication server that runs within our platform.
How big were the teams and how long did it take from start to the version we have now?
We started the team that did this to around 6-7 people, including 12. Currently, we have 4 developers, 1 tester, 1 scrum master, and 1 developer. So the current team that did this is around 7 people. So when we built it initially, Mission Impossible 1, we were more around 10 or 12, I think. Those were the proper members of the team, but as we said, we had a lot of support. Yeah, I think we need a bigger pipeline team, somebody working to creating the tools. You need somebody with a vision. Rui was there, had a great vision, microservices, apps as well, of course, was pushing relentlessly to go in this direction. Yeah. And it took about a year and a half, I would say, to get to where we are now.
The reality is that it's one of the practice of starting the business. Any new thing that starts a new project or this kind of stack will take from 135. But the fact that we're pioneers on this space itself, they got the first infrastructure for that, they got the DJs, everything. That itself, that's motivation also. It was a team, but it's the work of these teams that pioneers on behalf of the company that leverage opens the doors to the team that come after greatly benefit from it. And the upcoming course will be fairly simple to implement. And that's what it is. The next step is always to be super quick to get it out. I think the first is always a pain point. And it's painful.
Yeah, but we did have a lot of support. If you stop and think about these people really need the pipeline for us. The categorization service was actually built by another team and said, right guys, now it's your game, you look after it. Yeah. So we had a lot of people helping us, yeah. People taking bags from us and say, oh, that bag is really the old part of the code, or we'll take it. Yeah, the team was. It's hard work what they made, but it was also pretty.
I can suppose skillful and experienced people for such kind of migration. Juniors will not follow that, let's say.
Well, that's a good question. We have very good news in the Bundesliga, I have to say that, yeah. I've learned a lot from guys who are just out of uni, really, because some of them have really privileged minds, yeah. So, okay, thanks. I like, when you talk, some of the juniors we have, you feel like you're talking to equals, not to people below you, yeah. And also juniors often are more open, more susceptible to new things. I think you need a good mix. You need people with a vision, people with the ability to work and say, okay, I'll do it. Let's follow the vision. And people who are enthusiastic and say, yeah, hey, my first job in development, I love this. Yeah, wow, that's cool. Microservices. Yeah, sure. Yeah, that's it. Yeah.
Yeah, but don't underestimate the importance of the whole framework around it. The services have the communication framework in there, started talking about how to do this, the communication, so all these things, it wasn't there on the side. This is why it took them so long. The first my mission was the team was burned because there are no doors. I locked them in the room and there were no doors. They had to break through walls and find a way out.
Any more questions? Cool. Thank you very much.